GCSE Physics boosters, static electricity, right? This youngun's just been in the old wacky warehouse, bouncing around with all these plastic balls. Look at her hair. What's going on there? Well, that's what this video is about, static electricity. Imagine you have a balloon and a cloth, and you rub the balloon with the cloth, rub. And the balloon's tied to a piece of cotton or nylon thread, and you let go of it, and what happens is the cloth and the balloon attract each other. You can see that. Look at the angle of the string. So the cloth and the balloon are attracting each other. What's going on? Well, what happens is that when you rub the balloon with the cloth, some of the electrons on the cloth have gone onto the balloon. So the cloth has lost electrons and it has become positively charged. The balloon has gained electrons and it has become negatively charged. Which way round it is depends actually on the type of rubber or plastic and the type of cloth. But in this particular case, electrons have been transferred from the cloth to the balloon. So the balloon gains electrons and becomes negative. The cloth loses electrons and becomes positive. A mistake that a lot of students think is that positive charge goes onto the cloth. It doesn't. The cloth loses negative electrons and becomes positive. Protons aren't going anywhere. They can't. Why do they attract each other? Because one of the properties of charges is that opposite charges attract each other. It's called static electricity because the charge isn't going anywhere. Static means not moving, stationary. This is static electricity, not current electricity, static. The same charges repel each other. If we did it with two balloons on bits of string, this is a demonstration I do with a class whenever I do this topic, and the balloons repel each other. And that's because the same charges repel each other. Like charges repel. These objects are exerting a force on each other without touching. It's an example of a non-contact force. If things exert forces on each other without touching, it is called a non-contact force. Here are some examples of static electricity. Now, if an object gains lots of charge, then the charge on it is desperate to get off. If you like, all of the electrons on it are repelling each other like crazy. They really want to get off. And if it has enough energy, then it will jump to Earth and we will see a spark, which is what happens with lightning. The clouds up above us become so charged because of convection currents and things in the clouds. They become so charged. If there's enough charge, that charge will jump to Earth, and that's what lightning is. If an object is connected to Earth, then the charge can't build up because any spare charge will just go to Earth. So people who mend computers, for example, they wear a wristband which connects them to Earth so that they don't become charged. And this is to avoid any sparks. If there was a spark while they're putting in a motherboard or something, then that could damage some very sensitive components. So people who mend computers make sure they are earthed so that charge doesn't build up. A use for static electricity is in a photocopier. How a photocopier works is quite complicated, but one of the aspects is that static electricity makes ink particles go to where they are supposed to go. So the ink particles go on the paper in the right place, and then the paper's heated up and it melts and you end up with a photocopy. Electric fields. In A-level physics, we do electric fields, we do a lot about gravitational fields, we do magnetic fields. Now, gravitational fields are produced by masses. Magnetic fields are produced by magnets and currents, Electric fields are produced by charges. So the charge, the positive charge on this dome, this metal dome, which is part of a Van de Graaff generator, is positively charged, and it's producing this invisible electric field. The electric field is invisible, but we can represent the electric field by drawing these lines called field lines. Okay, and in the case of this dome, this charged sphere, the field lines are radial. They're going outwards like the spokes on a bicycle wheel. The arrows tell us the force that would act on a positive charge. So it would be repulsive, so the arrows go outwards. The field gets weaker the further away we are from the object, obviously. And you can tell this from the diagram because the lines get further apart. So this idea of an electric field, charges produce electric fields. I get my students to bring their hand, the back of their hand, towards the dome, and even before you get a shock, you feel the little hairs on the back of your hand stand up because you're in an electric field. If another charged object is in this electric field, then it will experience a force. Imagine these are like ping pong balls dangling on bits of string. And if the ping pong ball is negatively charged, then it's going to be attracted. It will feel a force towards the sphere. If the ping pong ball is positively charged, then the force will be repulsive. So whether the force is attractive or repulsive depends on the sign of the charge. Why electric fields? It's very, very useful. The idea of electric fields helps us to understand what's going on whenever forces between charges are involved. This idea of an electric field is very, very useful. Here, what have you got? This is a hydrogen atom. You've got a proton and an electron in orbit. Now, what's that got to do with electric fields? Well, why does the electron stay in orbit? And it stays in orbit because there's a centripetal force acting on the electron due to the electric field produced by the proton. There's a lot on this slide which is actually we're going to talk about in other topics. This idea of centripetal forces, the idea of atomic structure as well. But, you know, what holds atoms together, what keeps electrons going around protons, around nuclei, is an electrostatic force. If you like, it's the electric field produced by the proton, and then the electron experiences a force. And then lastly, another use for electric fields, you can use it to take soot, smoke particles out of chimney smoke. It's called electrostatic precipitation. And basically what you do is you charge the particles so that the smoke particles are positive and negative. They pass between big metal plates which are charged, so there's an electric field between them. The smoke particles are attracted to the metal plates, and so they're taken out of the smoke. At various points in time, there's a big hammer bangs on the metal plates, and then all the soot falls down and it's collected at the bottom and taken away to the tip or whatever.